Alright, so looking at section 6.5, this is on page 176 again, we are going to be looking at the properties of logarithms. So we're going to start right here in the middle and just talk about these properties. This is saying that if we have a log with a certain base, and we have two numbers that are getting multiplied, that's going to be the same thing as that log of that base of m plus the log of that base times n. That's not really intuitive at all, but let's look at a problem like this. Suppose that we're trying to evaluate log base 2 of 32, okay? We would think of this as 2 to the what is 32. And let's count it out. 2 times 2 is 4, times 2 is 8, times 2 is 16. So what's it going to be? 5. So the answer to this is 5. But there's another way I could have looked at this. Maybe I didn't know that. So maybe I would want to think of 32. Tell me two numbers that multiply to be 32. Any two numbers? 4 and 8. Okay. So 4 times 8 is 32. So based off of this property, I could say that the answer is going to be log base 2 of 4 plus log base 2 of 8. What is log base 2 of 4? 2 to what power gives us 4? 2. So this answer is 2. 2 to what power gives us 8? So do you see how that works? That gives us the correct answer for this. So that's why it might come in handy to break things down like this. With the quotient property, this says that if we have log base b of m over n, it's the same thing as the log base b of m minus the log base b of n. So let's look at another example. So maybe we have log base b of 1,000 over 10. Let's make our base 10, actually is what I meant to say. Log base 10 of 1,000 over 10. Well, let's break it up. So based off of this rule, it's going to be log base 10 of 1,000 minus log base 10 of 10. Well, 10 to what power gives us 1,000? 10 times 10 times, what's it going to be? 3. So this answer is 3. And then what's this answer? 1. 10 to the first is 1, or is 10. So 3 minus 1 is 2. So the answer to this is 2. But we also could have just simplified this. What is 1,000 divided by 10? 100. Would it be true that log base 10 of 100, would that also be 2? Yeah. So that's how those work. The third one is the power property. And this is this. If we have log base b of m to the n, we can just bring the n out in front. We could do this problem again based off of that. Look at this. Log base 2 of 32. 32 is 2 to what power? 2 to the 5th, right? We just did that. So another name for 32 is 2 to the 5th. This property says that we can bring that down in front. So I can bring this 5 down in front, and it would be 5 log base 2 of 2. Well, what is log base 2 of 2? 1 times 5 is 5. See how that works too? Okay, so these are properties. The sooner you can learn them, the better. Because we're going to be using these properties on the other page now. So flip over to page 177. And we're just going to do the odds today. So look at this. They tell us that log base 2 of 5 is approximately 2.322, and log base 2 of 12 is approximately 3.585. I'm trying to approximate log base 2 of 60. I could get out my calculator and do that, you know, with my change of base on there, but they want us to use this information to see if we can figure out another way to do it. So this would be log base 2. I want to use these numbers, 5 and 12. How can I use 5 and 12 to get 60? 5 times 12 is 60, right? What does multiplication turn into? Addition. So it's going to be log base 2 of 5 plus log base 2 of 12. And now we're just going to plug those in. So log base 2 of 5 we know is 2.322. Log base 2 of 12 is 3.585. And then we can just add those two. So just adding those. And we get 5.907. So really, if they're going to give you the base, there's not a great reason to do the problem this way. Because I could have just done this on my calculator. I could have used my change of base formula and done just log 60 divided by log 2. And I could have gotten the answer that way, 5.907. Okay? But on the ACTs, they always have problems like this, and they don't tell you what the base is. So they would just say log base B of 5 times 12. So if you would have to know this property because it would be impossible to do it on your calculator. Okay? All right, what about this? We have to rewrite this one so that we use only 12s and 5s. We got a 12. How can I rewrite 25 though so it's a 5 instead? Yep, I can make it 5 to the second. So now this is going to become log base 2 of 12 minus, because it's division, log base 2 of 5 squared. What am I allowed to do with that squared? Bring it to the front. Now I don't bring it to the front of the whole thing because it's only for this one. So I'm going to have log base 2 of 12 minus 2 log base 2 of 5. And now I can just substitute in log base 2 of 12 minus 2 times log base 2 of 5, and I get negative 1.059. Okay? So that's all you're doing, is trying to rewrite these numbers using only the numbers that they gave you. Okay? Questions on that part? Okay, what about down here? We're asked to expand the logarithmic expression. Expand means to use more logs. Okay? So right now we have log of 10x. We want to rewrite this and have more logs. We're going to expand it, make it larger. So what's it going to turn into? Does anyone know? Dexter?
Log 10 or log x.
Good. Now let's think about this. Do we know log 10? What's the base if we see log 10? 10. So 10 to the what is 10? Okay, that's what you guys are telling me, right? So that would be our answer then, 1 plus log x. All right, let's do number 7. This one's a little more difficult. Okay, so I've got log base 3 of x to the 4th. But what should I do with the 4? Bring it to the front, okay? So I'm going to keep that in mind, but I'm just going to do this one step at a time. The 3 is getting divided, so I have to make it minus log base 3 of 3. Also, the y to the third is getting divided, so I have to say minus log base 3 of y cubed. The reason both of those were subtraction is because they're both on the bottom. You can think about how they could also be thought of as to the negative 1 power, right? And the negative would come down in front. That's another reason. So now rewriting this, this is 4 log base 3 of x minus, what's this? Log base 3 of 3 is just 1 minus, what's this going to be? Well, the 3 comes down in front, that's not 1. That's going to be 3 log base 3 of y. And that would be the expanded logarithmic expression. Another way to write it that's expanded. Now we're going the other way, condense. What does condense mean? Make smaller. So this means we're going to make it smaller and we're going to use a single log. So anytime you see condense, that means you want to push it all together and make it 1 log. All right, so this one's pretty easy. Addition turns into what? Multiplication. So 3 times 8, so it's just log base 2 of 24. No problem there. This one, also addition. So we're going to have, but watch how I have to do this. It's going to be the natural log. What happens to the 3? It's now going to become a exponent, and it has to be for this whole 6x. That whole thing has to get cubed. This one isn't raised to any kind of power. So now what I would have to do is I'd have to say this is natural log, and I have to cube 6x, the whole thing. So 6 cubed is 216x cubed times 4y. Because addition turns into multiplication. And so I need to know 216 times 4, 864. So I'm going to have the natural log of 864 x cubed y. And that's equivalent to that. All right, let's do one more. We'll do number 13. Again, we're trying to condense. Now, we might want to reorder these first, because you see how things are negatives? So if they're negatives, they have to go to the bottom. I could also make this to the -1 power if I wanted, but I think it's easier to write whatever's positive first. I always rearrange it. And by the way, what is log base 6 of 6? I might as well just do that. What is that? You guys should know that. What is it? 1. I'm just going to put -1. And then this one is going to be just the same, log base 6 of 2y. All right. So watch how this is going to go. So now the only two things I have that have logs in them are these two. So this is just going to go out to the side. It's not a log, so it's not going to be involved in this condensing. So I'm going to have log base 6, and then is it just the 3 that gets squared, or is it the whole thing that's getting squared? The whole thing is going to get squared, so it's going to be 3x squared. This is subtraction, so this has to go on the bottom. The 1 is not a log, so it's just out here by itself, like -1. It's just not involved in the log part. So then my final answer would be log base 6 of 9x squared over 2y, and then let's put that in parentheses so it's clear that that -1 is not with the log. It's separate. Okay? So I know that's a lot of information. Hopefully that made sense. If not, you might want to read your book a little bit, get the hang of it some more. And you've got your assignment on your assignment sheet as well as on the board. Guys, tomorrow too we're going to do teacher talk day. That just means that I'm going to tell you like what classes you can take next year. So we'll do that, and then we'll talk about change of base.